So here's an introduction to the symmetric form, which is still an equation of a line. And it is given where x is over whatever is the x-intercept and y over the y-intercept equals 1. So this is different from our linear equation that we're used to, where y equals ax plus b. Do not get confused here. B is the y-intercept here, and a is the slope, whereas this is not your slope. So if we're given x over 3 plus y over 5 equals 1, well, we know that the x-intercept would be 3. Okay, so that would be our coordinate point. And the y-intercept would be 5, which then if you had to graph it, you'd be able to do that by graphing your intercepts, which would be your 2 points, where you would have 5 up here, 3 down here, and that would be your line, which as you see, this would be a decreasing line. But let's say we wanted to find a line that was parallel to this or perpendicular to this. Well, we have to determine what the slope is. So we're going to rearrange it into our slope-intercept form. Okay, so how we want to do that is get y by itself. So let's start by bringing over this whole entity to the other side through subtraction. So we get y over 5 equals 1 minus x over 3. Okay, and then we want to get rid of this 5 here. So we're going to multiply both by 5 or by everything by 5. And if you prefer to have your slope come first, we can do that. And I like to leave the fractions, especially if I want to determine what is perpendicular. So now we see that the y-intercept is still 5. So that's our new b, that's the b. And then this is our slope. So it's negative 5 over 3, which you can see here is a negative line. So if you had to find something that was perpendicular, the slope would be 3 over 5. Something that was parallel, the slope remains negative 5 over 3. But so there you have it. Symmetric form gives us the intercepts. And through rearranging, then you can get back to slope-intercept form and determine what else you need to determine.